right, so I'm recording. If you're not okay with that, too bad. No, just kidding. You can turn your camera off or something. Welcome, folks. Can you confirm that you can hear me?
Yeah, I can hear you.
Wonderful. I've heard my audio is not great at times. I've got an external microphone coming, so next week I should be all set with that. I wanted to start just by showing you. So first of all, I'd like to. Well, let me just say that I'd like to keep the course like as the same as possible. And I think I'm able to do that given the way I run it, given the fact that our tests are take home anyway. I usually use a document camera to write notes. I have a document camera at home. I think for the most part, we can keep things pretty much the same. The main difference is obviously going to be getting help is a little bit different. So instead of walking in my office, you'll have to, email me or talk in Google Hangouts. But again, I've got a document camera, and so like it's really easy for me to project a piece of paper and give you some help with stuff. And so that's my general plan here. To help facilitate that stuff, I have updated our Blackboard page. So I'd like to show you what that looks like. So I'm going to share my screen right now. Let me just mention a couple things about that too. So if you are not familiar with Google Meet, I think what happens when I start sharing my screen is that it creates two of me. It creates like a version of my screen, and then it creates the video. And so I'm going to show you my screen in a second, so you want to be looking at that one. Basically, they look the same right now because I'm looking at my Google Meet image, but I just want to show you how you can pin or unpin a camera if you wanted to. If you wanted to make sure that something stays in the middle, you can hit the pin button. And then there's various layouts you can change if you wanted to. I'd maybe recommend the spotlight one and just have it on the presenter, which would be me, and just pin it up there. Let's see here. Our Blackboard site has changed a little bit, so let me show you what that looks like. I've added a couple things to it. In particular, let's see here. I've added the Google Meet and Google Hangout links. And so the Google Meet link is the link you click to get here. It's going to be the same link all semester, so you can always find it on Blackboard or the email I sent out today. And then the Google Chats thing, I added us all to a chat along with Alex. And so these are all my classes, but this would be our class. That's got a Google Chat. And this is where Alex is going to hold his office hours. So he's going to hold his normal office hours on Monday and Fridays. I go ahead and mute whoever that is. It's Bradley. All right. So anyway, Alex is going to be in this Google Hangout like he was last night during his office hours. And so you can chat with him here, or you can just go to a video chat if that's helpful as well, along with him. That way you can share screens if necessary. You could look at like Maple stuff. You could potentially show images of math and things like that. And so this is where Alex is going to hold office hours. The other thing we should be aware of is, let's see here, my YouTube page. So you can see here, this YouTube playlist link will take you to this YouTube link. And when you click that, it'll take you to a YouTube playlist for our class. Now, I plan on posting like the video that's recording right now, I'm going to post in this playlist. And I'm also going to put in like, as we start moving into Fourier series, there's some YouTube videos I want us to watch anyway. And so I'll also put those in the playlist. So as soon as I hit stop recording on this, I will add the video to this playlist. Other than that, things are generally going to stay the same. Like the way you'll submit assignments is you'll go to the assignment tab here. And for example, project 1 and homework 4 are right here. And so project 1 is due today. And so you would go into project 1 and you would upload your project right here. I'm happy to I'd prefer if you had a scanner, if you scan things. But I actually just found this really great app for scanning on your phone. So what I'll just type this here, but I'll say like, scan your work if possible. If you don't have a scanner, download the app called Cam Scanner. I think it's just one M. I used it the other day, and it takes really, you take a picture of the thing you want to scan, but then it like puts it reformats it in the right way, and it like brightens it if needed, and it really does a nice job. And since we're going to be probably sending like pictures or scans back and forth, I would really, really, really appreciate if you would use that app. I would recommend you use that for any and all scanning for any of your classes. It's a really, really nice thing here. Add comments. Why did that not work? I don't know why that's not working. Anyway, you heard me say it. Cam Scanner. Please try to use Cam Scanner if you can. Maybe I'll just type that in here so you can have it written out. Cam Scanner. I would strongly recommend you try that. Okay. Thoughts about anything I've said? Do people have an issue with that plan? Like, I know there's potentially issues with either access to a computer, access to high quality internet. Are people still available at 2 p.m.? Are you willing and able to meet me here at 2 p.m. Tuesday and Thursdays to do this? Or would you rather I make videos and post them for you to watch? Basically, the way I'm running my other classes is I'm posting videos ahead of time, and then I ask people to watch the videos before class time, and then during class time, I just answer questions. So it's like a really shortened period where I'm just sort of like answering questions about the notes, answering questions about homework or projects or whatever, and so it's sort of like a flipped approach. And I'm doing that in other classes because there's a lot more people in those classes, and I know some people in those classes don't have internet or a computer or may or may not be available at the class time. So I was sort of thinking, since this is a small class, we might all be available at 2 p.m. normally, and we might just be able to like run a normal class where I can, let me just show you how that works. I've got a document camera right here. I can turn my document camera on. 1 second. And then I can change my camera over to the document camera and just like fill out notes like I would normally. My camera's just warming up here. Yeah, so it looks something like this, right? This is my document camera. I've got like my board right here. I could put up some notes and we could do the normal thing. I could zoom in on it, just like class, basically. So what are people's thoughts? Would you rather do something live, or would you rather me record stuff? This is where you can unmute yourself and talk, or feel free to use the chat if you're interested, but there's only a couple of us in here, so not that kind of expecting everyone to answer me here.
I mean, either way is fine for me. Like, 2 p.m. still works. And obviously, I have an internet access that works fine to do live stuff, so.
Okay. Other thoughts? Let me stop presenting here. I forgot I was sharing my screen. So let's see. Matt says live's fine. Bradley doesn't care. Nick, are you still not available on Thursdays?
No, I am now.
Okay. All right. So, and I think we lost. Oh, Zach's here. Zach, what do you think?
I have no experience with either, so I have no preference.
Okay. I'd like to go live, if at all possible. 2, 4, 6. Weren't there 7 people in here a sec? Oh, that's because I started presenting. Okay. So I'd like to stick with live then, if that's fine with folks. I do know that we're missing one person today, so Kwasi's not here. I know that he had some issues getting on today, so I was gonna maybe not start new material today and instead answer questions about the project or homework. I know I've been emailing a lot of people for both those things, but while I'm here, I've got my document camera. Are there specific things or questions from either one of those things that people want to talk about? Again, project or project 1 or homework 4. So homework 4, I was going to have due Thursday, and we can do the last problem together. That's something that I do want to talk about during this session. But outside the last problem on homework 4, are there other questions about that homework or the project? I feel like most people have gotten their questions out, but I just wanted to see. Are people able to do number 4B on the homework?
I haven't really started the homework yet, to be honest.
I appreciate that honesty.
Yeah, I was just working on I finished the project and I uploaded it, so I'm going to work on this tonight, obviously, and tomorrow.
Okay. All right, I'm going to talk about, so, it was a long time ago, but when we left off, I had some issues with the singular value decomposition. So let me say a couple things about that.
All right.
And then we can do the last homework problem, and then you can let me know if there's something else you want to look at here. So, okay. So on the last day, we had done this page. Let me zoom in here. Oops, too much. And then I had some issues with okay, here's the page that we were looking at. Okay. Is that like really light? It looks really light on my screen.
Yeah, it's pretty bright. A little better.
There we go, maybe. So everything on this page is true. Let me start there. So there wasn't like an error in the notes or anything. So the way we think about singular value decomposition is we're trying to take a matrix A and rewrite it as the product of U sigma V. And it's true that everything that says here, so the columns are U are the normalized eigenvectors of AAT. The columns of D are the normalized eigenvectors of ATA. That's both true. The entries on the diagonal of sigma are, in fact, the square roots of the eigenvalues of AAT or ATA. So those things are all true. What happened when we went to do this in class was that we tried to do it with this particular matrix, and I wasn't getting the exact matrix back when we actually multiplied the product out. And so here's what I've learned. Let me talk about this one. So it turns out this is a symmetric matrix, right? So symmetric means that the transpose equals the same as the original. So if you make the rows into columns in this one, that's what the transpose is, it would be the same, right? Because the first row is 2, 2, you make that the first column, it stays the same. Second row is 2, 1, you make that the second column, it stays the same. And so it's a symmetric matrix, and it turns out that with symmetric matrices, the SVD, the singular value decomposition, is complicated. This, again, is something crazy with this light here. Hold on, let me see if I can fix that. It's like too much light coming in my window or something like that. Try this. I hope that's a little more visible. Let me switch my pen color here. So with symmetric matrices, the singular value decomposition is complicated, is what I'll say. And one of the things that, one of the key features is that eigenvectors are not unique. And we did talk about that in the eigenvector section, because any multiple of an eigenvector is also an eigenvector, is what we had talked about. And so it turns out you need a scaled version of eigenvectors for symmetric matrices. And so I'm just going to kind of leave it at that. I'm going to show you what I mean, and I've updated a new Maple code, but that's sort of the short of it, is that because this was a symmetric matrix, I just kind of picked this one at random. I just randomly happened to pick a symmetric matrix. I was trying to just do a 2x2. I just found this one online. I just picked it. And it turns out that the SVD ends up being more complicated because it happens. That's just something I honestly wasn't aware of. And it took me a little time reading around the internet, reading some posts and stuff to look on that. I've got a great post that someone made that explains the situation. If anyone, I'm not going to bore anyone if you're not in. So let me just show you how that works in the Dropbox. So I uploaded a new Dropbox Maple file, and so you might want to open that. There's two in the folder right now. One's called matrix factorization, and one's called matrix factorization 2. So let me show you that. I'm going to share my screen again here. So here are those two files. Maybe I'll just give you 1 second to open them. You can let me know when you have opened them. Does anyone else need another minute to open up Maple?
Got it.
Okay, so this is the same file. What I've done is here's the matrix we were trying to do the SVD of. And remember, we also did just the diagonalization. So this first chunk of code works for the diagonalization part. The second is for the SVD. And so here I was doing AAT and ATA, so doing the transpose times the matrix, and you can see you get the same thing in both cases because the matrix is symmetric. In both these cases, you just get A squared, in other words. And because of that, the eigenvalues and eigenvectors end up being the exact same. And so you do want to normalize them just like we normally do. So we took the square root of the eigenvectors, or the eigenvalues, excuse me, and we put it on the diagonal. So this is the sigma matrix. That hasn't changed. And then I normalized the eigenvectors in the same order. So like, the 9 was associated with 2, 1, right? And so the 9 is in the first entry, the square root of 9. So that's why in the first entry, I'm going to use 2, 1. And so here I am just normalizing the eigenvectors again. And then U is what you get when you order the eigenvectors in normal fashion, corresponding to the way the eigenvalues work. So everything through equation 16 is still the same. The thing that's different, the thing that is tricky about this, is you want the eigenvectors in V to also be ordered the same way because they have the same eigenvalues, right? But here's what I was talking about. You need to scale the second eigenvector by -1 in this case. So you just take the same exact eigenvector. You can see the right-hand column here is the same in both cases, just multiplied by -1. And when you do that, and you do U sigma V transpose, you actually get back to the original. And so it's the scaled version that turns out to be needed when you have theory behind that, which is why you need the negative. Again, it has to do with it being symmetric, but that's sort of how that particular one worked. And I just wanted to clarify that, if nothing else, from before break. This is what I was struggling with last day class. Questions about that before we look at the homework problem? So the homework problem is not symmetric. It's not symmetric because it's not even a square matrix, right? Like if you took the transpose of this non-square matrix, it would just be, instead of being a 2 by 3, it'd be a 3 by 2. And so it's not symmetric, and so we don't have these weird issues of symmetric matrices. And so you follow the same process, except there's no weird, tricky thing. Okay, so here, so I've got A listed, I wrote down the transpose, and then we're also going to need to look at the eigenvalues of AAT and ATA. And so you can very clearly see that those are different matrices, they're different sizes for that matter, because we have a non-square matrix that we're working with. Here I am doing the same thing. Here I am finding the eigenvectors of the first matrix, AAT. This is how we're going to create the U vector, or the U matrix. And then the eigenvectors of ATA is how we create the B matrix. And so again, we put there, I've notated all this, but we put the square roots of the eigenvalue on the diagonal here. We normalize the eigenvectors again, except they're different now, right? So these ones for U are 2 by 1s, and these ones for V are 3 by 1s. But we still put them in the same order corresponding to the eigenvalues, right? So like this 6, in other words, this is the eigenvector associated with 6. Right, you can see that right here. And so when you put them in just the right order, with just regular normalizing them. So here I am with V again, just regular V. You don't have to like make the last one negative like we did in the last case. And when you do U sigma V transpose, you do get back to the original. I know this looks almost not like the original, but it's because when we took a square root right here and made this, this is square root of 8. And so it just rounded it to 2.8. And so then when we get down to here, it's representing square root of 2 as some numeric value. So when you multiply this highlighted thing times square, it's like square root of 2 times square root of 2, which is, right, so these two entries just equal 2. And so we do get back to the original by just following the regular method, no tricky things there, just finding eigenvalues and eigenvectors and putting them in the correct. So you're welcome to reference this for the last question in the homework, and really you can just copy things down is fine. The point of the SVD and all that matrix factorization stuff is to just give you an application of eigenvalues and eigenvectors, but also B, if you end up pursuing higher mathematics, whether it's in grad school or in your career or whatever, you may end up seeing these matrix factorization things in more complicated settings. So it's just nice to be a little bit familiar with them, like you've already seen them before, in the event that you might see it in grad school, for example. Because when I saw this stuff in grad school, it was the first time I saw it, I feel like, and it was a little confusing. Anyway, thoughts about homework 4? Last question, or singular value decomposition. I just talked for a little bit there. Happy to clarify anything I said. Anything? The other thing I should have actually showed you, let me show you one more thing. One of the reasons I was a little hesitant about starting today as well was because I wasn't sure if you had the notes yet. And so, in class, I had been printing out notes and handing you the note packets, right? And actually, I had chapter 5 printed out on the last day, but I didn't hand it out because we didn't start it. I really wish I had handed it out, obviously, now. So anyway, you're going to need to print out future course notes. And so if you go to course documents, you can see blank chapter 5 notes right here. And so I seen an email about this. I don't know if people saw it, but before our next class, you should print these 32 pages out because this is what we're going to pick up with live on Thursday. Again, I'm not interested in necessarily starting today because I'd like to give everyone a chance to finish the homework on the project, and also I'd like everyone to be on the same page. I don't want to lose Akwasi basically, and so I want to start together if we can on Thursday. So does everyone have access to a printer? Are you going to be able to print notes? Let me rephrase that. Does anyone not have access to a printer who might need help printing notes? Like I had to run to school. My printer is terrible. I had to run to school today to print things. Folks have printers? Wonderful. If you don't, let me know. I might be able to like snail mail you some or overnight it or something, if that would be helpful. Okay, I'm going to wrap up here unless there's other questions. I'm going to summarize what we're doing, but I want to make sure I can answer any questions anyone has. Anything else you want to talk about right now? Okay, so by Thursday at 2 o'clock, we're going to do a live session on this chapter, chapter 5. So you should print these notes out as soon as you can. I'll try to get the next chapter up there too, so maybe you can print those out ahead of time. There's homework, and there's the project is due today, which you'll submit under assignments here, and you'll submit the homework here as well by Thursday. On Thursday, I will have the next homework assignment, and I'll try to pass out the next project as well, and we can look through that. I think I'd like to do maybe like a project day as well for the second project, where we, especially since we're remote, it might be helpful to work on it together a little bit, and so we can think about that. Other thoughts, questions? Okay, so I'm going to stop this video. I'll see you back at the same link on Thursday. I'm not going to send a reminder out with that link, so just go to Blackboard if you need that link again. I'll try to basically reduce the amount of emails you guys get. You're probably getting a lot. But having said that, you should really be checking your email like crazy. Like if you're not getting emails pushed to your phone right now, you really need to like turn that on, because that's our life. I don't like it either. I hate getting school emails on my phone, but like that's the situation we're in right now. So I've been a little disappointed on the lack of basically responses from a few people. And so if you're not checking your email, please start doing that. And if you're just ignoring me, can you stop? Okay, anyway, no, I'm just kidding. And the other thing I should mention, I didn't mention before, I'm generally available like most times of the day, even night, potentially weekends, right? Where I'm at home doing nothing. And so I'm happy to like pop on and talk to you. So like shoot me, don't be afraid to do that basically. Don't wallow around in confusion. Send me a message and we can chat. All right, thanks guys. I appreciate it. I will see you on Thursday. Please make sure you're turning stuff in and you print stuff out so you're prepared for Thursday.